the aim, we're going to write this in linear form or quadratic form. The minute you see something that looks kind of complicated like this, most likely it's going to be like you would have to use substitution. So you're going to get linear form or quadratic form, and then you would have to solve, right? So in this case, we know that we're aiming for linear form or we're aiming for quadratic. We know that. Okay, so let's simplify. I see the 2x in brackets. So if I see that, what I would say to myself, okay, maybe for this question, I could let y be equal to 2x. Therefore, my aim would be to try to get the 2x in this whole equation, right? So let me show you what I mean by that. I don't want to lose anybody, so please tell me if you're confused. Okay, so what I would do now, I could say, actually, let me continue with the blue. I could say 2 to the power of 2x is the same as saying, remember I said just in this case that I am going to let y be 2x. Why did I say that? Because I see 2x in the bracket here. So most likely my substitution is going to involve 2x. So 2 to the power of 2x, I could rewrite this as 2x squared. My aim is to get the 2x, 2 to the power of x, right? So 2 to the power of x squared minus, I have my 12 to the 2x, and I have the plus 32 is equal to 0. If I remember, I said I'm going to let 2 to the power of x be equal to y. So just by looking at this, I can tell that this is going to be a quadratic, because this would be y squared minus 12y plus 32 is equal to 0. And this right here, this is a quadratic. How do I know that it's a quadratic? Because it's in the form ax squared plus bx plus c is equal to 0. So that's how I know it's in the quadratic form. And how do I solve quadratics? Well, the method that's most common is factorization, solving by factorization. If I solve this quadratic here, what I will get as my factors would be, actually let me do it the long way, because this is add math, and you would, if this was a question, you would probably get a mark for showing your factorization. So y squared minus 8y minus 4y plus 32 is equal to 0. Remember, we did solving by factorization already, right? And now I group them, and when I do that, I would get my factors equal to, okay, let me do it the long way. Be sure to write all of this, because you would most likely get marks, could be 2 to 3 marks just for this factorization, right? You don't want to skip anything out and then put yourself at risk at losing unnecessary marks just because you didn't write it out. So you know what you're doing, but just because you didn't write it, you lose like 3 marks. That's not good. You need as many marks as possible, right? So my two factors would be y minus 8, and my other factor would be y minus 4. Okay, equal to 0. It is going to continue up here now. So this is just solving by factorization. Yeah? We did this already. So y would be, I write in all these steps, because I don't want you to lose marks for skipping out steps. So you see all the things I have written here? That's what you expected to write, okay? Although you might see, okay, factors of y minus 8, y minus 4, that means y has to be equal to 8, y has to be equal to 4. Don't risk losing marks just because you didn't put this, right? Don't take anything for granted. Put the y minus 8 is equal to 0, y is equal to 8, y minus 4 is equal to 0, y is equal to 4. Okay, so now we know that y is equal to 8 and y is equal to 4. We know now that the second and final step is to solve, right? Can I erase this part here, the right-hand side, this holding?
Yes, ma'am.
Okay. I would leave the green part. Actually, no, I need to erase this green part. So the first part finished. That was our substitution, right? Now we solve it. And how do we solve? We said y, if y is equal to 2 to the power of x and y is 8, that means 8 has to be equal to 2 to the power of x. But unlike our other example, we don't have one value for y. We have two values for y. We have 8 and we have 4. So you can't just decide that, okay, I'm just going to use the 8, forget the 4, that's it. No, that's not what you do. You have to use both values. So 8 is equal to 2 to the power of x, and 4 is equal to 2 to the power of x. Do not just leave out that next number. You will lose marks, okay? It's very important. We said when solving exponential equations, we need to make sure that we have the same base. We don't have the same base here. We have 8, we have 2. So I need to find a common base. 8 can be written as 2 cubed. So I have 2 cubed is equal to 2 to the power of x. Now that I have the same bases, I could say, okay, therefore, x has to be equal to 3. 4 is equal to 2 to the power of x. Here, we still don't have the same bases. We need the same bases. That's the only way we could solve it, right? So 4 can be written as 2 squared, and this is equal to 2 to the power of x. Therefore, x has to be equal to 2. And since they asked me to solve this exponential equation, my answer would be, well, answers, x is equal to 3 and x is equal to 2. Everybody good with this?
Yes, ma'am.
Okay, so just do the other one for me, and that's the end of indices. I don't think we have time to move on to logarithms. If we do, well, I'll stop that one time. If we don't, well, next class. So just do this third one for me. I'll give you like 5 minutes. I'll give you 5 minutes to do this one before I go through it. Anybody got the answer for this one? Anybody? Nobody? There's a trick on this question. Just saying. Okay. Well, let me go through it then. So the aim we need to solve this. And you need to keep in mind, when solving exponential equation, there's a possibility of getting, there's a possibility of reducing the equation that they gave you to its linear form or its quadratic form, right? So always keep that in mind. And as you continue to practice, it will become easier to you, right? So I'll start off by just simplifying my equation. I know that there is a possibility of me writing this in its linear quadratic form, so I need to keep that in mind while simplifying. Okay, if I simplify this, what you're going to get is, okay, so let me do this the short way. So this, the long way. This is the same as 2 to the power of 2x times 2 to the power of 3 plus this is the same as 2 to the power of x times 2 to the power of 3. And this is equal to, they told me, 1 plus 2 to the power of x. So now that I see 2 to the power of x, and I know that there is a possibility of me writing this in its linear quadratic form, I see 2 to the power of x. So in my mind, I should know there is a possibility that I'm going to let y, so remember for the substitution method, I use y, but you could use whatever letter you want. So I know that there is a possibility of me letting y equal to 2 to the power of x. That's just a possibility, yeah? Okay. So now I could simplify this even further. 2 cubed, that's 8. And 2 to the power of 2x can be written as 2 to the power of x squared. So by now I would know, okay, for sure, I need to have, I'm going to do substitution. If I let y equal to 2 to the power of x, I know for sure I'm going to have a substitution here, right? But like I said, as you practice, it'll come easier to you. 2 cubed, that's also 8. And then we have 2 to the power of x. And this is equal to 1 plus 2 to the power of x. I said I'm going to let y equals 2 to the power of x. So I could rewrite this entire equation as 8y squared plus 8y is equal to 1 plus y. I could rearrange this equation because remember, the goal is always to write it in its linear form or its quadratic form. I could tell that this is going to be a quadratic because of the squared. I see y squared. So I know it's going to be a quadratic. So just the people who came in late, quadratics are like this. It's in this form. So most times, the minute you see this squared, you're probably dealing with a quadratic, right? And you know, when solving quadratics, there are 3 ways to solve it, but the most common way is the factorization. So this becomes 8y squared plus 7y. How did I get 7y? This one, I'm bringing everything to one side, right? So minus 1 is equal to 0. I just brought everything to one side so I could get this equal to 0. Yeah. Why do I want it equal to 0? Because we know when solving quadratics, we set it equal to 0, right? That's just from quadratics when we learn quadratics. To solve a quadratic, it's always set equal to 0. And that's why I brought everything across to one side so I could get my quadratic equal to 0. Once I have it equal to 0, I could solve it, right? This particular quadratic can be factorized. So I would solve it by factorization. Or you can use the formula if you're comfortable with that. So this would give me 8y plus 8y squared, my bad. 8y squared plus 8y minus y minus 1 is equal to 0. This is solving by factorization. Okay, so remember to write out all your steps because you'll most likely be marked on that. And if you skip it out, well, you just lose unnecessary marks there because you know what you're doing, but because you didn't write it, you don't get the mark. So just erasing this with some space, erasing this too, space. Okay, when I factorize this, this is going to be 8y, y plus 1 minus y plus 1 equals to 0. So my two factors are y plus 1 and 8y minus 1 is equal to 0. Remember, when solving by factorization, you put each factor equal to 0 and solve for the unknown, right? In this case, the unknown variable would be y. So what I mean is that we just solving for y, right? So y plus 1, we put that equal to 0 and solve for y. So y is equal to minus 1. Next factor, 8y minus 1 is equal to 0. So what does that mean for me? Y is going to be equal to an 8. But we know we don't stop here. Those are my values for y. Now we actually have to solve the exponential equation. That was solving the quadratic. Now we need to solve the exponential equation. So y, let me use this one first because there's something I need to show you with this value. So we said we're going to let y equal to 2 to the power of x. And we said one of the values for y is 8. So we could say 8 is equal to 2 to the power of x. But remember, when solving exponential equations, the only way I can equate my indices is if I have the same base. I don't have the same bases here. I have an 8 and I have 2. So what I need to do, I need to get the same base. How exactly do I do that? You look at your laws of indices and you determine which laws you can use to simplify this to get the same base. So I can say 8 is the same as 2 cubed, and this is equal to 2 to the power of x. And we know from our laws that 1 on 2 cubed is going to be the same as 2 to the minus 3, and this is equal to that. Just in case anybody does not know how I got this here, the law says that a to the minus n is equal to 1 and a to the power of n. So 1 on 2 to the power of 3 is the same as saying 2 to the power of minus 3. And that's how I got 2 to the power of minus 3 here. So 2 to the power of minus 3 is equal to 2 to the power of x. Now that we have the same bases, 2 on 2, I can equate my indices. Therefore, my value of x is going to be minus 3. But that's just one value. You don't just neglect the other value. No. You have to use the both values. So that's it for an 8. I get x is equal to minus 3. So we're good with that?
Yes, ma'am.
Okay. I'm just going to erase this now because I need space and I don't want to confuse you with what I'm going to write now. So like I said, there was a little trick here because I didn't show you this before. But now thinking about it, I would include it in these lines. I wasn't planning on showing you this until we do logs, but I'll show you now anyway. So this is what I'm talking about. So just like before, we solving the exponential equation. So I would say, okay, y is equal to 2 to the power of x, therefore minus 1, because the value is minus 1, is equal to 2 to the power of x. But what I need you to remember is that, see this number here? This number can, hold on, can never, ever, never be negative. It cannot be negative. This is invalid, right? So your answer for this one was, oh gosh, this may be, was x is equal to minus 3. But for this one, it is invalid. So just for now, just know that it's invalid, right? I'll show you why it's invalid when we start logs. That's why I was planning to start logs today, but we wouldn't have the time. So just for now, know that this number can never be negative. When we start logs next class, I'll show you why it can't be a negative number and why this right here is invalid. Or you could put inadmissible. So inadmissible. Or your teacher might say no solutions. So whatever, right? Invalid, inadmissible, no solutions. Okay. What is very important, I need you to remember, because people also mess up on this, because they would say, okay, this number could never be negative. Instead of putting the word invalid or inadmissible or saying no solutions, they just leave it like this. That is actually not correct, because just like x is equal to minus 3 is a solution, this would also be a solution, right? You have to tell them that it's invalid. You would get a mark for saying that it's invalid. If you just say minus 1 is equal to 2 to the power of x, I just leave it like that. No, you have to put the invalid, inadmissible, or no solutions. I don't particularly like using this no solutions thing, but if your teacher tells you to use it, well, you can go ahead. But you can also say inadmissible or invalid. Be sure to put it. If you do not put it, you lose a mark for no reason. Okay, so that's just 1 mark on that, because you didn't put that one word. You have to, okay? So everybody good with this?
Bye.
Yes, miss. I think so.
You think so? Think so. Oh, I need you to know so. If you have any questions, let me know. Huh? Any questions at all about this? If you want to query me about this, like I said, I would show you why it's invalid when we do logs. But if you want to know right now why it's invalid, I could show you that too, if you want me to. So everybody good with this?
Yes,
Yes,
miss.
Okay. Well, congrats, because that's the end of indices. So we finished logs, we finished indices, and now it's just, no, we didn't finish logs. We finished surds, we finished indices. And now it's time to do logs. So I don't have enough time to do logs today. So we would continue that next class. If you have any questions about the topics we did so far, please let me know. Any questions about the questions we did today, please let me know. And yeah, that's it. So you can leave now if you don't have any questions.
All right, bye, Miss.
Bye, Miss.